An inscribed angle is half of its intercepted arc. So what I'm going to do here is I am going to create myself a diameter. And the best way to do it is to actually insert a line. Watch this and just go here. And then connect the dots, la, 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 la. And press escape. And then hit Command H. So I've got myself this pretty little thing here. So what I'm going to do now is I can take this and I can go ahead and put that over there. And then I want to ask you guys, whoops, if you were to, I'm going to put this pen down for a minute because I don't think I need it right now. I'm using my little annotator. When I need it, we'll use it later. Okay, so I'm so distracted. Okay, so if I wanted to find the measure of this angle, clearly this is an inscribed angle because, again, it's formed by two chords, right? By two chords, and it intercepts this arc. If I were to ask you, knuckleheads, what is the measure of this arc, you should all tell me that it is, please say 180 degrees, because it is. So here's what I'm going to show you, that is if I go ahead and measure this angle, looky here, it's actually 90 degrees, and no matter how I move the vertex around, right, if I move this and I swing it around, it doesn't matter. That inscribed angle is always going to be 90 degrees. And hence we have ourselves, even if I swing it around this way, noticing that angle does not change, so it's always going to be 90 degrees. So when we intercept a semi-arc, that means the inscribed angle will always be 90 degrees. So that's something we can actually say. When we intercept, let me just say this, when an inscribed angle, let's make inscribed angle intercepts a semi-arc, the measure of the angle is always 90 degrees. Now you guys know, as well as I do, that I can go ahead and start asking you fabulous questions based on all of that, okay? Because we have right angles, we can remember there's always trigonometry. I can bring trigonometry to this party now that I have this beautiful thing. So SOHCAHTOA is going to come here, Pythag is going to come in here. We can find the, areas, perimeters, and all that. But this is a huge piece of information that we have right over here. Now, just so you know, this angle A is also an inscribed angle because it intercepts arc BC. So just, if I were to just curiously to find the measure of that, oops, you know how temperamental this can get. Anyhow, we have this. If I measure this angle, right, angle, that angle is, they're saying, is 27.4 degrees. So if you wanted to predict what the measure of that arc is, you should all be saying, oh, it's 27.4, turn this on, 27.4 times 2, and that would give you 54.8 degrees. So I'm going to show you that, in fact, it is. And there's a clever way that you can actually measure an arc. I think you can do it. Just wish me luck. I have never tried this live. 3 here. Oh, come on. So 1.2.3 point. Okay, and then you can construct here. You see where it says construct arc through 3 points. And now, can I measure the arc angle? Look at that. So I can now measure the arc angle. And the arc angle is 54.79, which technically it should be 54.8 degrees, which is what we said it was. Okay, so this arc is going to be double that arc, which is kind of cool. And if I just swing my thing around over here, it's always going to be double. That arc is always going to be double, which is just fantastic. So you are learning lovely things here. There is another glorious, glorious thing. I'm going to go to here and go to Document Options. And we're going to add a page. And going to a new, why didn't it do that? Document Options. Add a page. Oh, blank page. Okay. So in the same document, that's how I create the tabs, by the way, for those of you who are curious. I'm curious what happens when I inscribe a quadrilateral. Quadrilaterals, how many sides, friends? You guessed it, it's 4 sides. If I inscribe a quadrilateral in a circle like this, whoops, we got to do this right. If we're going to do it, we got to do it right. Here, 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 and here. So if I inscribe a quadrilateral, what I'm curious about is what's going on with the opposite angles. So this angle here and that angle there. So if I were to measure that angle, okay, I can go up here and hit my little measure angle. Come on. It's going to be 86.81 degrees, which I'm going to put here, right, which is this. And then I'm going to measure his friend on the opposite side, this guy here, and I'm going to hit measure, angle, and I'm going to do this guy here. So now, if I were to calculate where we are, here we are, measure, calculate, check that out. If I were to take this angle plus this angle, hit OK, look at what that measurement is, and I hit OK, it actually tells me that the sum is 180 degrees. And what's more is even if I spin this around, even if I don't know why that angle didn't change, but it's weird. Okay, but when I measure that angle, I know why, because you got to grab, it's not that one, it's going to be, is it this one? Yeah. Okay, so if I grab this, no matter what, those opposite angles are always going to be supplementary. And that should also work for the other friends at the party too, which I'm going to do here. And if I hit measure, angle, I get 76.74 for that guy. And if I do the opposite angle to that, and I hit measure, I'm going to get my angle, and that's going to be 103.26. And again, we're going to go to measure and hit calculate, and we're going to grab this angle, and we are going to add it to this angle and hit OK. And sure enough, it's 180 degrees. So the nice thing is, what I'm going to say to you is no matter how much I spin this around, right? If I take that point and I spin it around, those angles are changing. If I take D and I spin those around, those angles are still going to be supplementary. Now my question is that's all well and good, right? So one of the things that we're going to say is, I'm going to move this down a little bit, and I'm going to leave it up to you guys to figure this out, okay? I'm a hot mess. I'm going to leave it to you guys to figure this out because I think it's super important for you guys to do this. So one thing that we can go in here is another thing that we know that, yes, of course you want to put it into your notes, that the opposite angles of an inscribed quadrilateral are always supplementary. That deserves a cap too. Now that does. Okay, come on. SU. Supplementary. MENTARY. Okay? They're always going to be supplementary. So the opposite angles of an inscribed quadrilateral are always supplementary. Now, the question I'm going to ask you is, and that's going to be something that you're going to have to answer for me at some point, is why does that make sense? And that's something that you're going to have to come up with. Like, how come this angle here, right? Think about, that's the angle, right? Here's the angle. And then here's the other angle. And that's the arc that this is intercepting. This is the arc that that is intercepting. How come the angles themselves are going to add up to 180, knowing what you know about inscribed angles and their arcs? So I'm going to leave you with that thought. But then we're going to go over, we're going to answer this question. So you were asked, so let's say, for example, you're given something like this, right? So you can clearly see that we have ourselves an inscribed quadrilateral. And remember, there are things that we know about this inscribed quadrilateral is that we know, first off, is that the opposite angles are, ding, 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 you got that, supplementary. So right now, I'm told that this is 90 degrees, so therefore I know that his friend over here is also 90 degrees. Right, because they are supplementary. And then the other thing is if he's 108 degrees, then A is going to be supplementary to him. So we know that A is going to be 72 degrees. Now, interestingly enough, what I want to show you, okay, I'm going to go to display line width and make this line. I have to actually highlight a line. So what I'm going to do is I'm going to highlight this because, hold on, TW and WE create this angle where A is at, right? So I'm going to highlight those, and I'm going to go to thick, and I'm going to change the color to something a little more, I don't know what it is. Look at this. I don't know why this happened this year, that's actually done that. So that right there is your inscribed angle. So what I'm going to do to really hone in on this is I'm going to create, come on, Char. I'm going to create the arc, because arc THE is the one that's doing that. So if I go ahead and construct arc through 3 points, we know that that's the arc that intercepts this angle. So therefore, this entire arc is going to be double of whatever 72 is, and then 72 times 2, my friends, is 144. So this big arc here is 144, which means we can find the measure of arc HE. So if we do 144, whoops, minus 96, right? 144 minus 96, that tells us the measure of this arc right over here is, 48 degrees. So we have that this guy here is 48 degrees, and we can go about our way. Now, looking at the 90 degree, we can actually find all the other, most of the other angles. So right here, this guy is 90 and that guy is 90. So again, if I were to highlight the arcs that make up this guy, I'm going to go to display and change the color to, that's still yellow. Look at that. I didn't mean for that to happen. I'm going to go to the second one. All right. So those are, and I'm going to make this thick so we can go to construct the line thick. Okay. So this right here, so now we have that this is our inscribed angle WTH, okay? Don't say anything bad, no bad words, you guys, okay? So what I'm going to do is I'm going to show you the arc, that is arc HEW, that intercepts that angle. So we are going to do an arc through 3 points for that guy, right? Remember, that's the ice cream scoop that I talk about. So it's this, I don't like that it didn't do that. I want to change the color on that. Hold on, because I want you to see it. You deserve to see it. So if you guys are like, I already know what it is, and that's, I know some of you are saying that, but get over yourselves, okay? So the first thing we're going to do is construct arc through 3 points, and then I'm going to go change the color of that real quick, okay? So just bear with me, and there you go. So I don't know why it didn't show both. That's super interesting. So it's an arc through 3 points, but my point is if this is 90 degrees, then the measure of arc hue is 180. So we have to do 180 minus 48 degrees to find out what the measure of arc EW is. So 180 minus 48 is, in fact, 132. So I'm going to go over here, and now we know that F is equal to 132 degrees. So we know that this arc is 132 at F. Now, I still want to find the measure of arc TW, even though I didn't ask you to find it. By the way, I don't know why I found that. Oh, I do know why I found that. Oh, we're going to go answer some questions that I didn't put on here because it's fun. I want to find the measure of arc TW. And again, if I want to find the measure of arc TW is being combined with HTW. So HTW intercepts this angle right here, which is this guy here. We're going to go display. We're going to go line width. We're going to go thick on this one too. I hope some of you who were struggling with seeing it are starting to see it a little bit better. Come on. We're starting to see a little bit better now. So that's going to show us that this is the arc here. And if this is 90, then arc HTW is 180. So if we want to find this arc right here, we're going to do 180 minus 96. Okay, so 180 minus 96 is going to give us 84 degrees. So this guy over here is going to be 84 degrees. If you don't have your calculators out, you're going to want to go get them. Just trust Mama Schwa, okay? The reason why I say that, even though this doesn't look like it's drawn to scale, so what I'm going to do is I'm going to be that girl, and I'm going to move this over because there's a method to my madness. Because if I were to draw in, this is basically telling me that if this is 90 degrees, that I should be able to connect from here to here, and technically the center should be going through there. So that's my flaw. I never should have put a 90-degree angle there. So I'm just going to let that go, and we're going to go on to a new figure. So check it out. Let's just start scratch from new so that we can all figure out what we need to do. See how I make things rhyme even when you're not with me? Okay, so again, point, intersect that one there. Sure, why not? That there. And then this here. Okay, so I'm going to make this bigger because we can. All right. So for you guys, I'm hoping that, like, if you're, let me see what I can do here. No, I know what I'm going to do. Watch. I'm crazy. Crazy girl. Crazy girl. All right, so we're going to take this and we're going to, whoops, get out of here. We're going to, come on. I thought this was the one that could swing. Yes, it can. All right, so what I'm going to do, I know what I'm going to do. Get rid of these two for now. Just bear with me. Command H, get those out of there. And then put a point. Bear with me, you guys. I love that you're live, that I'm doing this. Well, not live, but I'm kind of doing this on the fly. See what I did there? All right. This is so cool. All right, so move this out of the way. This makes the circle smaller or bigger. We don't need him. But what I want to show you guys is, check this out. This is a diameter, right? We all know it's a diameter. So I hope you guys grabbed your calculators because I want to show you something. First of all, you should all be able to tell me the measure of this angle and the measure of that angle because this is a diameter, that's a central angle, so we should all know that this guy here is 90 degrees, as is his friend over here is also 90 degrees. Now, let's say I say that the diameter of the circle, the diameter is, how old are you knuckleheads? Diameter, come on, I'm not a good speller. I am a good speller, I'm not a good typist. The diameter is, say, 18 centimeters, okay? Now, let's go further. So this is going to be 18 here, so let me put an 18 on this guy, 18 centimeters. And if I want to find the circumference is 2 pi r, or just pi times diameter. But if I want to get the area, I can easily find the area of my circle and all that, because the radius would be 9, and then 9 squared times pi would be 81 pi for my area. But I want to make this more interesting. Let's say that this arc here is 126 degrees. Okay, 126 degrees, and I want to get, and let's say the measure of this arc over here, because they're not going to be congruent to each other, is 108 degrees. And I want to know how to find the area of both of these triangles. Okay, I want the area, how about this? I want the area of the quadrilateral, just for fun. And then there's a couple of other things that I'm going to show you as we do that. So if this arc is 126 degrees, that means that this arc is going to be supplementary to it. So 126 minus 180, well, 180 minus 126 is 54 degrees. So this dude over here is 54 degrees. So going through here, life is like a puzzle. Isn't this just fabulous? And then, and then if this is 108 degrees, then his other arc over here, his friend here, is going to be 72 degrees, because those arcs have to add up to 180. And the sum of all 4 arcs should be 360. Now, remember, this is 72 degrees, so follow it to your inscribed angle. So if you said that that's 36 degrees, you are awesome. So this is going to be 36 degrees, right in there. And then you could find this angle 2 ways. You could do 90 and 36 minus 180, or you could do half of 108, which I'm going to do because it's so fast, and say it's 54 degrees. Okay, so this is going to be 54 degrees here. Okay, right there. And then we can go up to the other triangle here, and 54 and 126, and half of 126 is 63 degrees. So this angle here is going to be 63 degrees. Okay, so this angle is 63 because it's half of his intercepted arc. Remember, there's the 2 chords. Remember, diameter is a chord, the longest one. And then half of 4 is, what, 27, right? 27 times 2. I really need to start turning the lights on because I can't see anything. And then this is going to be 27 degrees here. 27 degrees here. We know all of that, right? I want to see, I want you guys to notice 2 things. First of all, the opposite angles here are, you guessed it, supplementary. If I add those 2 angles together, right, 54 plus 36, no, 63, that's my dyslexia, okay, that gives me 117, and that means that this should be supplementary to that, because 36 plus 27 is 63. So if I add 63 and 117, I am going to get 180 degrees. So the opposite angles of noticing that this is a quadrilateral, that yes, I did break down into 2 triangles, but it's still a quadrilateral nonetheless. The opposite angles, because they are inscribed in the circle, are supplementary. 90 is 180, 54 is 63 is 117, this is 63, they add up to 180. But I want you guys to find the area, of the quadrilateral, which means find the area of the 2 triangles and, you guessed it, add them together. So if I were you at this time, I would pause this thing and I would go about my business and do what I need to do, okay? But since I'm here, I'm going to keep going here. I'm going to use, it doesn't matter which one you use as your reference angle. I'm going to use 27 because that's the one that I'm staring at. And I want to find this side first. And I will go ahead and call this side X. I will call this side K. Why not? I'm going to call this guy V. I'm going to call this guy, because it's right there, as U. Okay. All right. So now, if I want to find the things that I need to find, excuse me, I am going to do for the first one is going to be, whoops, get out of my way, sine of 27 degrees is equal to X divided by, you know what I'm going to do? Watch me, I'm such an OCD person. X divided by 18. because if you notice, a diameter of a circle is also a hypotenuse of a right triangle. Okay? All right, so we're going to do that to find that one there. Then we're going to, watch what I'm going to do because I'm so lazy. I'm going to copy and I'm going to paste. But I'm going to rewrite this as the cosine of 27 is equal to, k over 18. And then moving along, get out of my way. Why is this being so temperamental? Like a teenager. Hit Control V again. I am going to use 54 degrees because I'm looking at it now because it's, no, we'll do 36. We'll keep it there. 36 is equal to, this time it's going to be V over 18. And then it's going to be the cosine, whoops, I have a Control V, right, because we do the cosine. Cosine of 36 degrees is equal to U over 18. So then on my calculator, I'm going to wind up doing 18 times this. Oh, let's make sure I'm in the right mode. Oh, I was in radians. Ooh, that wouldn't have worked. Okay, so that's going to be 18 times the sine of 27. So this is 8.17. Whoops, 0.17. K is going to be 18 times the cosine of 27. That's going to be 16.04. Okay. U is going to be equal to 18 times the cosine of 36. So that's going to be 14.56. And again, I really hope that you took the time to just do this on your own and then check your answers with what I have here because it's just really good for you and it's good practice. And then 10.58 here, 10.58. Okay, for that guy. So now if I want to find my area, right, it's going to be 1, oops, watch what I'm going to do because I have OCD. So it's going to be 1/2 times, what is that, 10.58 times 14.56 plus, and then I'm going to copy this guy here. Or whatever, it's taking too long. And then again, 1/2 times, this one here is going to be 8.17, right, times 16.04. And then that will give us, let me do it now, times 10.58 times 14.56 plus, oops, not plus, I want to do times 8.17 times 16.04. 04, and that gives me 142.5458, so that's 142.5458 square centimeters, because it's area. So it's going to be squared, and there we have it. So a couple of things to remember is that an inscribed, when a inscribed angle intercepts a semi-arc, it's always going to be 90 degrees. And the opposite angles of a quadrilateral are always going to be supplementary. So those are really cool things for you guys to think about. And I'm going to assign some problems for you to do. And at some point, I will have extra help, little sessions for us to all to meet on. I hope you guys had fun.